Students, before we move on to the properties of Laplace transform, let me just give you a shortcut of how to do the Laplace transform problems without applying the integration formula. Okay, if you listen to this shortcut video, all you have to do is just simply apply the basic formulas that you have studied earlier. You don't have to apply the integration. Okay, and in order to find the ROC, usually to find the region of convergence, I have to apply the integral formula. If you remember, the integral formula is minus infinity to plus infinity x of t into e raised to minus st dt. I have to apply that formula in order to find the ROC of the given question. But here in this shortcut video, I'm just going to give you a brief explanation of how to find the ROC without applying any formulas. Okay, so this is some of the basic formulas. Okay, so suppose if your signal is multiplied with u of t. Okay, so if the signal is multiplied by u of t, you all know what is u of t, right? What is u of t? This is u of t, right? This is u of t. Right, this is called as u of t. Okay, so if a signal is multiplied by a u of t, then that signal becomes a right-sided signal, right? That means the graph of that signal is only on the right side, because on the left side u of t is 0. So 0 into the signal becomes 0. So this becomes a right-sided signal. Okay, so when I find the Laplace transform of the signal, I get my Laplace transform x of s as your answer. Okay, this signal can be any signal. It can be a sine or cosine or u of t or e raised to minus at, anything. Okay, so in any of these signals, if you find the Laplace transform, it will be x of s. Okay, so now how to find the region of convergence, or how to find the value of sigma, or the real part of s. Okay, if you remember the property number 4, if you have studied in the regions of convergence, the property number 4, it states that if x of t is a right-sided signal, then the region of convergence, the real part of s, is defined as real part of s greater than some constant a, where a is nothing but a pole in x of s. Yes, x of s, a pole of x of s. That means the denominator function of x of s. Okay, this is how we find the Laplace transform of a right-sided signal. Okay, how do you know it is right-sided signal? Simply look at u of t. If the signal is multiplied by u of t, immediately understand it is a right-sided signal. So if it is a right-sided signal, then your Laplace transform is x of s, and your real part of s is greater than a. This is how you define the ROC of that particular Laplace transform. Okay, where a is the pole of x of s. Okay, now suppose if I multiply that signal with u of minus t. Suppose if I multiply a signal with u of minus t. Okay, what is u of minus t? This is u of minus t, the time reversal of u of t. That means on the negative axis. This is u of minus t. Okay, so if I multiply the signal with u of minus t, then that signal will become a left-sided signal. So that signal will become a left-sided signal. So when I'm going to find the Laplace transform of that signal is also x of s. All you need to do is simply put a minus sign in front of it. Okay, all you need to do is simply put a minus sign, a negative sign in front of this, then you'll get the answer correct. Okay, you don't have to apply any integration or anything like that. Just simply put a minus sign in front of x of s. That means if the signal is a left-sided signal, put a minus sign in front of it. Okay, that is what. Now how do you find the region of convergence? Okay, if you remember the property number 5 of region of convergence, the property number 5 states that if x of t is a left-sided signal, then your region of convergence, yes, is determined by the equation real part of s is less than a. Yes, less than a. That means a is the pole of x of s. Okay, less than a this is how we find the region of convergence. That means if it is a left-sided equation, then the real part of S will be less than A. Okay, if it is a right-sided signal, then real part of S is greater than A, where A is the pole in X of S. Okay, so likewise here in this example, I have already put a minus sign over here. Okay, so here minus sign over here, so minus x of t into u of minus t. All right, so that means minus of this means minus of minus becomes plus, so this will become x of s. So that means if you look at this formula and this formula, the Laplace transform is exactly the same. That is, the Laplace transform of x of t u of t is also equal to the Laplace transform of minus x of t into u of minus t. Right, both of them are having the same value x of s, but one thing is understand, this is a right-sided signal, whereas this signal is multiplied with u of minus t. So therefore this signal is a left-sided signal. So if it is a left-sided signal, then the ROC is defined as real part of s is less than A. Okay, this is how you define the signal and its the Laplace transform of the signal and its ROC. Okay, so likewise similarly, just humor me. So that means if I find the Laplace transform, okay, if I want to find the Laplace transform of a signal that's look like this, that is minus x of t u of t. Okay, minus x of t u of t. In that case, then what is my my Laplace transform? It will be minus x of s. Okay, and what will be my ROC? Since this signal is multiplied u of t, then that means it's a right-sided signal. So that means your ROC will be real part of s greater than A. You see. So all you need to know is simply understand whether that given question is a right-sided signal or a left-sided signal. If it is a right-sided signal, then this is the Laplace transform, and whatever you get the denominator, it is real part of s is greater than that denominator. At the same time, if it is a left-sided signal, simply put a minus in front of that same answer, and your real part, your ROC, will be less than, okay, A. For example, let's do for example, let me give you an example. Suppose I want to find the Laplace transform of e raised to minus at u of t. Okay, we all know what is the Laplace transform of this. E raised to minus at u of t. What is the answer? It is 1 by s plus a. 1 by s plus a. So here, how do I find my ROC? Okay, so here the denominator is s plus a, so that means the value of s is minus a, right? That means the pole is minus a is the pole, s is equal to minus a is the pole. So how do I find my ROC? My ROC, since the ROC means I have to find the value of real part of s. Okay, so my pole is minus a is my pole. Okay, and real part of s. So since this is a right-sided signal, then the real part of s is greater than minus a. Okay, so suppose if I write over here the Laplace transform of e raised to minus at u of minus t. Okay, suppose if it is u of minus t, then my Laplace transform is simply put a minus sign in front of it, minus 1 by s plus a. This is the Laplace transform of e raised to minus at into u of minus t. Okay, now if you want to find the ROC, here the pole is s is equal to minus a is the pole. Alright, no need to write the pole. So here the real part of s and minus a is the pole, right? So since this is a left-sided signal, as per property number 5 of region of convergence, since this is a left-sided signal, the real part of s is less than minus a. Understood? Less than minus a. This is how we define the Laplace transform as ROC without applying the integration formula. Okay, so all you need to learn is the Laplace transform of the standard signals, those basic formulas that I've showed you in the earlier video. That signals and all you should study very hard, and on top of that you need to understand the properties. So next I'm going to teach you about the properties. Okay.